For a long time, the scientific community maintained that colossal black holes, the so-called supermassive black holes, occupied the center of all large galaxies. Yet, despite sustained efforts, none had been identified within the galaxy known as the Southern Pinwheel Galaxy, also called Messier 83 or M83. This spiral galaxy is located about 15 million light-years away. Its absence left researchers puzzled, still convinced that such an invisible giant must be present. Today, the powerful James Webb Space Telescope seems to have uncovered evidence suggesting that a supermassive black hole may indeed be lurking at the heart of M83. These cosmic giants feed on vast amounts of gas and dust, emitting extremely intense light in the process. And yet, M83 showed none of that characteristic glow. Could it simply be hidden behind thick clouds of dust? In fact, the telescope's advanced cameras detected concentrations of ionized gas, a phenomenon that occurs precisely when a black hole swallows surrounding matter. In short, this black hole may be playing hide-and-seek, and James Webb may have finally lifted the veil on this persistent enigma. But what exactly did the researchers observe? They detected a glow from neon gas that requires an immense amount of energy, far greater than what ordinary stars can produce. This luminous emission is strong evidence of a hidden active galactic nucleus. Even the most violent stellar explosions, known as supernova, do not release enough energy to generate such radiation. Therefore, the hypothesis of a supermassive black hole seems the most plausible, though not the only possible explanation. The light could also result from shockwaves traveling through interstellar gas. To decide, scientists plan to probe the region with other high-precision space instruments, such as the Hubble, ALMA, and the Very Large Telescope. At the same time, this discovery highlights the capabilities of the James Webb Space Telescope, which now seems able to reveal phenomena long beyond the reach of previous observation tools. Among other examples, it has contributed to the detection of a supposedly impossible black hole. Yet, this discovery may not have been as astonishing as it first appeared. Let's break down the mystery. Astronomers initially believed they had identified an extremely voracious black hole, devouring matter at a rate 40 times higher than the accepted norm. Such a phenomenon would clearly violate the known laws of physics. This black hole, named 568, was spotted by the James Webb Space Telescope. It dates back to the very early universe, having formed only about 1.5 billion years after the Big Bang. At first, everything suggested that this insatiable black hole was consuming far too much at an abnormally rapid pace. Such a rhythm would have caused a dramatic and surprising growth at such an early stage of the universe. Under the light of new Webb observations, researchers realized their mistake. The black hole was not breaking any rules at all. What had been interpreted as excessive consumption was actually an illusion caused by a thick cloud of dust partially obscuring the view. Here's, in principle, how black holes work. When matter falls into them, it heats up intensely and emits bright light. A rule known as the Eddington limit states that the maximum amount a black hole can absorb directly depends on its mass. If it tries to consume more, the radiation it produces pushes the matter away, preventing further absorption. Some black holes can slightly exceed this limit, a process called super-Eddington accretion, but never at rates 40 times higher. According to initial estimates, object 568 seemed to violate this rule spectacularly. But a new study, published in April 2025, showed that the black hole was actually feeding at a perfectly normal pace. The initial error came from limited visibility due to cosmic dust, which blocks and scatters light, making observation more difficult. In the end, what seemed to be a cosmic glutton turned out to be a rather ordinary celestial object. Frustrating, isn't it? Researchers explained that when a black hole is hidden behind a dust cloud, as with lead 568, It is essential to adjust brightness measurements by accounting for the dust in order to estimate its mass correctly. Without this, the results risk being skewed, distorting calculations of the famous Eddington limit. In this study, the team estimated the mass of the black hole using infrared light, which is less sensitive to dust opacity than visible light normally used. Thanks to this method, they discovered that the black hole is nearly 1 billion times more massive than the Sun, about 40 times higher than the first estimates. This new measurement allowed them to correct the Eddington limit, showing that the black hole was neither as voracious nor as strange as once believed. Its behavior does not indicate unusually rapid growth. Scientists already knew that dust could bias black hole measurements, but they had not always managed to correct for this distortion when observing distant galaxies. It is therefore very likely that other black holes were also mismeasured, leading to incorrect interpretations. The new method developed by the team may help scientists deepen their understanding of black holes hidden in galaxies shrouded in dust, including the so-called little red dots recently revealed by James Webb. During the first analysis of these remote regions of the universe, researchers uncovered a previously unknown phenomenon: clusters of tiny galaxies with an extremely deep red glow. These celestial objects, nicknamed little red dots, number in the hundreds and seem to appear only during a brief period in cosmic history, about 1 billion years after the universe's birth. They puzzle astronomers because they show traits of two very different entities. Some appear like massive galaxies filled with stars, while others resemble small galaxies hosting a giant black hole at their core. One thing, however, is certain. The typical little red dot galaxy is tiny, barely 2% the size of the Milky Way, and some are even smaller. What then makes these galaxies shine so brightly? Two main hypotheses compete. One suggests that a little red dot contains an extraordinary number of stars, up to 100 billion, equivalent to the Milky Way, even though its size is much smaller. Imagine an immense, silent, empty space. Now place within it the population of an entire large country compressed together. That might be what the inside of a little red dot looks like, one of the densest places in the universe, so concentrated that some scientists doubt such density is even possible. The other theory proposes that these red dots are compact galaxies with a colossal black hole at their center. Scientists can detect such objects by studying how gas moves around them, producing a specific kind of light. And indeed, this signature has been observed in many little red dots. The most surprising aspect, however, remains the size of these black holes, far too massive for the tiny galaxies that host them. Normally, a black hole accounts for just about 0.1% of a galaxy's mass. In some of these dots, however, it could almost equal the galaxy's total mass. This is so unusual that scientists call them oversized black holes. But one last mystery persists. While conventional black holes emit X-rays, those in little red dots show no such trace. Even with specialized telescopes, researchers have been unable to detect any signal. It is as if these black holes are still playing hide and seek, eluding our current observational capabilities.